Hi, environmental methodologists. I just recorded this lecture and I got through it and it was completely wrong because of technical reasons and I had to delete it. So here I am a second time in a row saying the exact same thing alone in my office. This is crazy, but we will get through this. Okay, speaking of going crazy, what do you do when this happens? And this interpretation of the meme is I am overwhelmed by mathematics and I have no idea what's going on. My brain has shut down. What do you do when that happens? Well, as I mentioned, I suffer from this problem myself. That sometimes when faced with a problem, I don't know, something happens in my brain and I start freaking out and I'm unable to do analytical thought, which includes mathematics. Instead, I'm fearing and anxious, etc. So what do you do? Well, I mean, the first thing is you can't really do anything about it. You've got emotions, you've got to experience them, you're having a physiological reaction, you have to deal with that. Sometimes that means maybe one of the best things to do is just to say, I got to step aside for a few minutes, take a few breaths, get something to eat, get a drink of water, cry, whatever. Just get it out of the way and like, okay, I'm ready to go back to work. Come back to work, and then what? Do the same triggering thing? I developed this 9-step method for those of us who just we can't think for the moment. It's sort of a trampoline, a safety net. It's trampoline. It's a safety net for those of us who our brains have shut down or we can't figure it out. It's not for dummies. I used to call myself a dummy a lot until one of my students said, I don't think you should call yourself a dummy. That's not helpful for your own mental health. I'm like, wow, you're right. And so I don't say that anymore. Instead, I write it and then I cross it out for people like me who have this problem. So how's it work? Okay, here's how it works. Remember, the key here is, for the most part, this is so that you don't have to think. You just got to read the stuff and follow the instructions without thinking about it. Number one, so it's a crazy word problem, and you have to say what is given in here. What are they giving me? Unit-wise, what units are they giving me? In a herd of 34 elements who each pass 27 gallons of methane per minute. Oh, 27 gallons of methane per minute. That's given. Write it down. Just write it down without thinking about the problem at all. And put a box around it to separate it from everything else. And then the question is, well, what do you want? Or what does the person writing the question want? What do they want in terms of units? In the end, they're going to want, I don't know, boxes of bananas eaten by elephants per meter methane. I don't know. Someplace in there is going to be a question. Now, one of the problems here is that it's a cognitive problem. Is they're writing something out. It's all in words, in English. And in there, you have to convert that English question into mathematical symbology. So cubic meters of methane per elephant is a mathematical expression and might be buried in there in some complicated English construct. So you have to think to a certain extent to get these things. Sorry. So what do you want? The best, just write it down. For instance, years or acres or grams carbon per year. What do they want? Figure it out, write it down, put a box in it. You now know what is given and what is wanted, and you have boxes around those things to sort of isolate them, both physically on your paper and mentally in your brain. Now, back away from all that writing and interpretation and just try to figure out, what do you think the answer is? Like, how much methane is an elephant going to give off? Well, I've heard that a cow can give off 55 gallons of methane a day. So an elephant probably 10 times that amount. I'm just going to guess that. Okay. So, and as I mentioned before in a different essay, different video, a different lecture on making estimation, just guess and pay attention only to powers of 10. I'm going to sneeze. Thank you. All right. So guesstimate the answer and write it down too. So you've written down 3 things, put boxes around them. What is given, what is wanted, and your guess. And you will refer back to these boxes later on. And by the way, before I move on, sometimes I have a student who's having a problem figuring this out, and they're having a real problem, and I really want to help them. And so I say, hey, how's it going? They're like, just can't figure out this problem. And I say, where are you on the 9-step method? And they're not using it. That student needed to use the 9-step method because they're having a problem figuring it out. If you're having a problem figuring it out, use the 9-step method. Then a helper like me can come in and say, where are you? And I'm on number 3. I can't guesstimate. Then I can help you with that. Or I'm on number 2. I don't know what they want. Oh, okay, let's read this together and figure out what they want. Follow the method and literally do what it says. Write it down, put a box around it. I'm going to ask you to do that. Number 4 is strategize. Now, many of you are gifted, more gifted mathematically than I am, and you really don't need this 9-step method. That's great. You go ahead and do it. I'm still going to require to use the railroad method that I will explain in this video, so keep listening. But you don't have to do the rest if you don't. But for the rest of us, we're not strategizing. I don't want you to strategize. This is so you don't have to think about it. Just do number 5, which is set up the equation using the railroad track method. I'm going to explain that in a moment. So just all you have to do is throw stuff into the equation, into the railroad track. Just throw it in, and you have units, 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 and then you can flip things around until the units cross out, and you magically get what was wanted. It works great and requires next to no thinking. Sometimes you actually have to look up. If you just can't get the units to flip to get what you want, you might have to figure out, oh, I need one more bit of information, and then Google that. So that's life. Sometimes you have to look some stuff up. To do so if necessary. Once you have your railroad track, which I'm going to show you in a moment, once you have it set up and things cross out and it should give you the right answer, you just have to do the arithmetic. So you use your calculator and write down the answer, include the units. Just ignore sig figs and scientific notation for first. That's your first answer, the answer that comes rolling off your calculator. That's it. Just write it down and put the units in, and then you're ready to go on to number 7, which is simply just check it. Does it make sense? A lot of times the answer you get first does not make sense because there's an error in there. That happens. We make errors, and use this system to catch those errors so you can go back and fix it and make it right. So if your answer makes sense, does it make sense? If not, go to number 8, which is troubleshoot. If it does make sense, go to number 9. So number 7, 8 is troubleshoot, which is usually go back to 5 or 6. Go back to setting up the equation and doing the arithmetic. Usually there's a calculator error, or maybe you just didn't set it up right in the railroad tracks. Once you figured that out, fix it, you come back through here. Your answer should be closer to your guesstimate, and then you can go on to number 9, which is you're almost done, but not done. You have to adjust your first answer to scientific notation and significant figures. In this class, the default requirement is in scientific notation and significant figures. Sometimes we can get away with not using those, but if you're not sure, then use scientific notation and sig figs. On the midterms, every time I give midterm, I've told students this, and yet they forget and they lose points because they do not express things in scientific notation when that is the default expectation. Anyway, number 9, adjust for that. That gives you the second answer. Write it down and you're done. 9-step method, please use it. Okay, it's really helpful. Hi, how many times do I have to say this? It's really helpful if you struggle with this stuff. I guarantee it. All right, here's some examples. I want to make biscuits. I cook, and I have a recipe. Make 6 biscuits per batch. I want 9 biscuits because I have guests coming over. Also, a complication. The recipe is European, and it follows the metric system, like grams. I have teaspoons. The recipe calls for, this should be 1.5. That's the benefit of shooting the same lecture twice, is you know where you screwed up the first time. The recipe calls for 1.5 grams of baking soda. I don't want grams, I'm American, I use teaspoons. How many teaspoons do I need in my recipe? Can't figure it out, so I use my 9-step method. What is given? 6 biscuits per batch. I'm gonna think a little bit here. Guys, sorry, sometimes actually does help. I want 9 biscuits. I want, and I can mathematically am good enough to realize that's 1.5 times. I'm gonna have to multiply the initial recipe by 1.5. All right, so if I do that, I get 9 biscuits per 1.5 batch. So that's the units I'm gonna use. I have 1.5 grams baking soda per batch, 1.5 grams of baking soda per batch, because this is wrong up here. Actually, I don't know whether it's right or wrong. I just made these numbers up. And then I wasn't consistent. But now I'm going to go with 1.5. And then I have to think here and add one more thing. There's something that's not given that I know I'm going to need. They're talking about grams. I want teaspoons. So please, someone, God, provide me with a conversion, or Google, provide me with a conversion of grams per teaspoons of baking soda. So I Googled it. And I get 1 teaspoon baking soda per 4 grams. Okay, that's all that's given. I'm done with that step. What do I want? What do I want? I want teaspoons baking powder per 9 biscuits, right? Keep your eyes on the prize. That's what I want. I need to know how much teaspoons to put in there. So number 3 is my guess. My guess is about 1 teaspoon. I don't know. I've made biscuits before. Have you? It's not 1/10 of a teaspoon, and it's not 10 teaspoons, so it's somewhere around 1 teaspoon, something like that. Also, since I just made up the stuff in this problem, it's possible that things get really crazy. But anyway, that is my guess. All right. Now, strategize if that's how you swing. That's not how I swing. But anyway, whether you strategize or not, you got to use a railroad track method. Can't strategize? Great. Just chuck all of what you have into the railroad track method. Now I'm going to describe that. The railroad track method looks like this. It's the way that you can do this on paper. If you've done stoichiometry in chemistry, maybe you use parentheses. This parentheses times this parentheses divided by this parentheses, and you got messy as hell unless you're gifted and you're neat. And it works. It works. This is the same thing, only expressed differently. Instead of parentheses, we have little boxes. This is a railroad track, is it? All the railroad tracks I've ever seen have 2 lines, but they have 1. It's called railroad track method anyway. Whatever. And these are the supports for the rail, I guess. Anyway, the numbers you put in each box are multiplied across. So this number times this number times this number. And below the rail, you divide the top by the bottom. So just multiply across, multiply the bottom. What you're going to do is you figured out that you're given a bunch of units, and somewhere in there is a magical combination that's going to give you the answer. Do not think about it. Just dump them in there. Just stick them in there. I'll show you how to do it. Here it is. I've preloaded this. Whoa. I have to escape. Okay, so here's my units. Just not thinking, do not think, just stick them in here. And then the principle is, okay, once they're in there, we're going to multiply across the top and then multiply across the bottom and divide the top by the bottom. And like things get crossed out. So batch and batch gets crossed out. And anything that's not crossed out is what you're left with in the end. And in the end, we want, I can't remember, I think teaspoons per 9 biscuits is what we wanted, right? Yeah, I want 9 biscuits. I need to know how many teaspoons to use. So I got so now look at what you got. I've got teaspoons on the top, and I want biscuits on the bottom. The way you read a fraction is the top per the bottom. I want teaspoons per 9 biscuits. Hey, guess what? One of the cool things about these unit conversion problems is you can flip them. It's mathematically okay to flip them any way you want, upside down. That's fantastic. Takes some people to a little while to get used to it. Watch what you can do. I want to flip this upside down, so I'm editing now. Control X. And then home. And then put you downstairs and put this upstairs. Boom. Now I have, oops, batches per biscuits, and I put this back in. I can do this. It works. And let's see. What's going on here? Wait a minute. Uh-oh. Hey, cool. So I want teaspoons per biscuits. That's good. But now batches is upstairs, which means this batch needs to go downstairs. So I need to swap this around too. Bear with me, please. Oops. Did I do that? Batches on the bottom, biscuits on the top. Delete you. Okay, put this back in. Flipped it upside down. Easier to do with a pencil. And batches cross out. Grams of baking soda. This is also grams of baking soda. Grams cross out, and I'm left with teaspoons per 9 biscuits. That's all I'm going to show you because I don't feel like showing you the math and how it comes out. But once I do the arithmetic, I should check against my guesstimate. And if it's wrong, I need to troubleshoot stuff until this matches my guesstimate. Full disclosure, again, I just made up these numbers. I didn't really have a recipe, and so they might not come out close to your guesstimate, but in real life, they should. And then you would go on to do the arithmetic and then truncate for significant figures and convert to scientific notation. Let's think about sig figs here for a second. Which of these units are measurements, which are the only ones used in sig figs? Well, it's a little bit confusing because while I'm going to measure baking sodas per batch, it's kind of given. I don't know if that's 1.5 gram a measurement or given. It was given by the recipe, so I don't know if anyone actually, measured that. 1.5 batch per 9 biscuits, that's also not a measurement. I knew that there were 6 biscuits per batch. Was that a measurement? Ooh, this is a complicated one. I will say for certain that the gram, or the teaspoons for gram, that is definitely a measurement. If you think about that, teaspoon is a unit of volume and gram is mass. Those are not the same things. And also I know that a teaspoon of uranium is going to measure a different weight than a teaspoon of baking soda. So for sure, that's a measurement. And if this was the only thing measured, it would just be 1 sig fig. Sometimes if they're different, you do the best you can and then you argue it out with your teacher or your colleague on whether it should have been a sig fig or not. Okay. The important thing in here is the 9-step method and your use of it and your understanding of the railroad track method. If you have any questions about that, ask your lab instructor, ask me. We expect you to be using it. Okay, let's see what happens if I go like this. I gotta always do this, and we're gonna move on. Next question, same kind of thing. You've dropped out of school and want to make some cash growing vegetables at the farmer's market. And you want to figure out how much money. Hey, that sounds cool. Who wouldn't want to grow tomatoes and go live as a farmer? You want to figure out how much money you'll gross on each crop. Well, actually, when you think about it, do you really want to do it? I've been a farmer before. I liked it. I liked it a lot. But if you've never been a farmer before, you might think it's not so nice. On the other hand, not everybody likes things the way I do. But I sure liked a lot the money. Oh, that's kind of why I put this together. The money when farming, that's tough, especially if you have kids. Anyway, you want to figure out how much money you'll gross on each crop. And start thinking about tomatoes. How much money am I going to make per crop of tomatoes? And here's what you want to know. How much money will I make per 100 square feet of tomatoes? I don't know why you want to know that, but that's what the question is. I want dollars per 100 square feet, which is over here, what I want. Sort of skipping ahead, that's number 2. Number 1 is, what are you given? Anyway, here's some other stuff that you're given. Tomatoes sell for $3 per pound. I just made that up. I don't know what they really gross for at the wholesale market. But let's just say $3 per pound. And each plant takes up about 4 square feet. So I can have 1 plant per 4 square feet, 1 plant per 4 square feet. And each plant produces 2 pounds of tomatoes. Really? Okay, it's a pretty healthy plant, I guess. 1 plant per 2 pounds. I wrote that down. Here's what's given. Here's what we want. I did a little bit of thinking. I know that I kind of had a premonition that I was going to get dollars per square foot, which is fine. If I get dollars per square foot, I'll settle for that because I know I can just multiply it by 100 to get dollars per 100 square feet, right? That makes intuitive sense. So that's what I'm going to do. Oops. So I have to do it this way. Well, just the next thing is just dump it in here. See what happens. Will I get lucky or will I have to flip stuff around? I don't know. It doesn't matter. I'm not thinking. There. Oh no. I want dollars per square foot. I got dollars. I got square feet. And I got to get rid of these plants. Okay. Oh, I can flip this upside down. So I go like this. There. Let's see if that works. Hey, if it doesn't work, I'll do something else. So pounds cross out, plants cross out, and I get dollars per square feet. I multiply it by 100. I get my first answer. Then I have to check that against my guesstimate. Hey, how much money do you think you're going to get per 100 square feet? 100 square foot is 10 feet by 10 foot. How many plants are in there? Each plant, 20 to 25 plants. I don't know. I can almost do it in my head. I'm going to guess $100. Not $1,000, more than $10. I'll guess $100. I'll let you do the math. Well, get $6 per 4. It's 1.5. So, oh, it's pretty close, about 150 bucks. I'm going to skip the discussion on significant figures because it gets as weird as the previous one does. Measurements, $2 pounds per plant. I know that's a measurement. Not so sure about the other ones. Okay. So, back to our lecture. I want to show you a little bit of a more complicated, or introduce you to a more complicated problem with maybe a little bit more, I don't know, they're all real world, I guess. Teaspoons for biscuits and dollars per tomatoes. How about this? I've heard that eating apple cores can kill you. Have you heard that? Can they? I don't know. I've eaten apple cores and I didn't die, so what's the deal? Well, the deal is that apple seeds contain cyanide, and cyanide is a deadly poison. Why is it a deadly poison? You don't have to read this, but you can if you want to. I like biology. Cyanide is also found in peach pits, mango pits, manioc, and almonds, but I heard it could kill you. But I know manioc and almonds, I eat them, and I do not die. So some people say, therefore, eating any of these things will kill you. I say, calm down. I ate them and I didn't die, but what is the deal? So the deal is, yeah, cyanide can kill you, but a little bit of it won't kill you. It's a matter of risk assessment. Eating a molecule of cyanide is not going to kill you. Eating your weight in cyanide probably will kill you. A more refined question is, what is the lethal dose of apple pits? How many apple pits would I need to eat before I died, or before I had some threshold medical event? So you're going to work on this problem in lab, but I would suggest you try solving it before lab to impress everybody. See what you can do. You're going to have to think about it and come up with get some information and make some estimates, like, you know, average person, how much they weigh, lethal dose, that kind of thing. You could do it. You'll do it in lab even if you make no progress on it before then. But here's the deal, guys. I and your lab instructors, we are going to require everyone to use the railroad track method for setting up equations. Occasionally, I've had students who are really like, oh, I don't want to. I use a parentheses. It works great for me. I'm like, you know what? You're not too old to learn a new thing. So please use the railroad track method. You will find it works really good. It's neater. And after this class, you can go back to using parentheses if that's what you want. But in this class, railroad track. Also, heads up, if you have a problem figuring out the stuff this week or in future weeks, one of our first questions is going to be, so where are you on the 9-step method? Because if you're having problems, it means you need to be using the 9-step method. And if you're not, great, we need to know that so that we can get you back on track using the 9-step method. So heads up, we want you to use it. It's so great when a student says, oh, I'm on number 3 here, like I'm not quite sure what all the units are. Oh, I can help you with that. And once you're done with that, you can go to the next step and it will work. Okay, so that's why we really kind of shoehorn you into this method because it's tried and true and works. So that's all. Good luck this week. Look forward to helping you. I know you're going to go to your lab instructors for help first or the tutor also, but I can help too. So just reach out. Looking forward to it. Okay, bye-bye.